we are starting with today's Codeforces contest 845 and byte trace 23. Problem number A. Let's start with this one. So you have been given T number of test cases. Every test case contains a number n representing size of the array. Then you have been given an array of n integers, and then you have to return minimum number of operations required to form a good array. Okay. So this was pretty observation based problem. Let me tell you what the observation was. So basically, yeah, simple and direct, straightforward question. The array you have to give, you have been given, you have to tell the minimum number of operation required to form a good array. What is a good array? Good array is something like which do not have adjacent all adjacent element have different parity, do not have equal parity adjacent element, so that's a good array. So currently 1 7 11 2 and 13, if I just talk about this case, 1 and 7 same parity, so it's not good. And 7 and 11 same parity, not good. 11 12 good, 2 and 3 is good, right? 11 2 is good and 2 and 3 is good. So these, how many you just need to count the total number of adjacent elements which do not have good parity. 1 7 gives you one pair. Total number of pairs which do not have adjacent pairs which do not have a good parity, because what you are essentially doing, you are just taking two elements, two adjacent elements, you are just which are having same parity, you are deleting both of them and introducing their product. Now the good thing to notice is just what happens when you do this operation. This operation is actually nothing. This operation is actually nothing. It's like the answer for this would be coming out, the total number of pairs which are having same parity. So 1 7 is such a pair, and plus 1 for 1 7 11 is such a pair, and that's what the answer for this one should be. So its answer for this one is 2, exactly 2. And then the answer for this one is 3. Yes, let me tell you why. Currently I'm just calculating. Okay, so let's talk about, the we'll discuss this case later. The answer will come out like just the, like in this case, two adjacent element having same parity. Now let's see how the operations are happening. For 1 and 7, they are having same parity. You have to do one operation. It's like absolute truth. You have to do the application. You have to do all the operation. You cannot, say that, okay, I'm not doing an operation. So even if you do and 7 comma, so basically yeah, the logic lies in the statement odd into odd is equal to odd in every case. Even into odd is equal to even. That's obviously true, and can be like understood very well. But odd into odd is also odd. Okay, so 3 into 5, 3 into 7, any case you can type, or basically, yeah, you can check. Odd into odd is also odd. So these two, this is the overall logic of this problem, that the two, if the two elements having same parity, 1 comma 7, even if I do operation, they will remain same parity, they will remain 7, which is odd. Then I'll check, okay, 7 comma 11, now these two become adjacent. Okay, and 7 and 11 is again same parity, odd, so you'll multiply both of them and then it will become 77, same parity will remain, but now the adjacent element have been removed, something like that which happen. So you have to do, for every adjacent pair you have to do one operation. This is the whole logic about this problem. How you get this logic? By this concept, like odd into odd is odd, even into even is even. So 1 comma 7, there is only one way to make this pair good, by just removing them and then adding this. Okay, so there is no other way, and it will become something else. It will not become even in any case. Look, if it becomes even, if it becomes 4 4 11 2 13, this is good, but this cannot become 4, because yeah, 1 comma 7 are odd. So if it was 4, it can become 4 in only one case, like, yeah. But in this case it's already good. Okay, so in this case it's all the elements are already good. You don't even need to do that, right? You don't need to do 1 into 4 is equal to 4, because everything is fine, like in this case, odd even odd. So that's about it. You just need to see elements which are having same parity and adjacent element. Then you have to do operation for that. So in the t number of test cases, c in test case, while t minus minus int n, c in n, int an, c in the array. It's also simple. Int I, c in ai. After that, you just calculate for int I equal to 0, I less than n minus 1, I plus plus, if a of I modulo 2 is equal to a of I plus 1 modulo 2, then you can just say z plus plus, and then you have to print out your z. So one line of code basically, but just one line is that you have to check adjacent elements, no matter how you do it, in one line or in 45 lines, but the question is just this. Okay, z is not declared for sure, and z is equal to 0. Yeah, you have to remove the. You can also check for this, the total number of pairs, adjacent pairs having the same parity. Okay, so let me store it into R. So 1 comma 1, yeah, plus 1 comma 1, yeah. Now 1 comma 2 is good parity, but 2 comma 2, yeah. So answer for this is equal to 3, and that is the answer for this one. You will see. Just let's see this answer for this one, what it is. It should be 3. Okay, 203. That's fine. Let's submit this up and move to problem number B. Contest is over. Okay, so I think it's not accepting submission for now. So let me just show you my submission, which is kind of accepted. So this is the straight one line logic. If the parity of AI is equal to parity of AI plus 1, Z plus plus, and I have to do for all adjacent elements, so 0 to n minus 1 only, right? Because n comma n plus 1 doesn't form a good pair, right? So that's about it. Yeah, let's move to problem number B. Again, pretty standard and straightforward question. You have been given t number of test cases, a number n, and the integer. This integer can be anything into range of 1 to 10 to 5. You have to return the sum of beauties of all the permutation. Permutation is what you know. If you have been given number n equal to 5. So permutation is every combination of 1, 2, 3, 4, 5. Every permutation of this 1 2 3 4 5 is a permutation for this 5, right? So this is a permutation of 5 4 3 5 1 2. This is also permutation 4 1 2 3 5. This is also one permutation. Yeah, these all are permutation. You need to store the not store, you need to just print the sum of all the beauties of the all permutation. What is beauty in a permutation? Actually what you are doing with this permutation. So for example, this n, you generated all the permutation, but what you need to do, if permutation is p, you need to generate an array of size 2n, which is equal to p concatenated with p inverse. Okay, p reverse. Okay, we convert with inverse. So if this is equal to p, let me write it. This is equal to p. Then reverse of p would be something which you can just easily figure out, but by just reversing 5 4 3 2 1, and array would be equal to like a of I. A of I. Array consists of two n numbers. Okay, so array basically, let's say just array consists of such okay, so first of all, you got P, you got reverse of P, you need to concatenate that. So let's write concatenate. CC is equal to P plus REV reverse of P, which is equal to, if I just concatenate 1, 2, 3, 4, 5, 4, 3, 2, 1, between this there is one more 5. So this is some kind of a CC like concatenated pair. Also, you can form concatenated pair for this one, 2, 1, 5, 4, 3, and 5, 3, 2 1 4. This is the concatenator, this is the mirror position, you can also see. Yeah, and after this what you need to do, you need to push all these into this array A, something like this array is formed by all such concatenated permutations, right? So after having this array, you need to tell the sum of beauties of all these permutations. So let's forget about this array A. We are not storing this permutation anyway. So because that will take n factorial kind of space, we are not storing that. But that's what you need to do. You need to generate all the possible permutation, and then you need to do in reverse, and then you need to generate all the possible CC. You're not generating, you're just calculating in your mind. You're not like storing it anywhere. After this, how the calculation will happen. So it's also pretty simple if you do one or two test cases. So it's not observational based problem, it's like pattern finding problem. So pattern finding problem, basically for every 5 it will form pair with again the 4 numbers. So for 5 I will have 4 plus 4, because both of the 5 will always pair up with let's say currently this 5 is now what is this pair. Basically you need to see this generated permutation which you just concatenated. You need to calculate the number of inversions present in that. That is the beauty value of this permutation. So number of inversions, you also know it is something like where index is increasing but value is decreasing. For example, 5 comma 4 is an inversion, right? So 5 comma 1 is also an inversion. So index I is less than index j, but value of j is lesser than when but value of I is greater than the value of j. So this is inversion when I and I is less than j, and v of I, value of I, is greater than value of j. This is inverted way. So concatenations and this much and this one. And now what you need to do exactly, basically what is the answer for this one? So 5 will give you 4, both the 5 will give you 4 4. And again I'm saying that you will understand this after taking so much examples, but both the 4 will give you 3 3, which is just 1 lesser than 4, so 3 3, and both the 3 will give you 2 2. You can see which 3 pairs are giving this 4. This 4 is concatenating with 3 to 1. This 4 is forming inversion. Similarly, this 4 is forming an inversion. And This 3 is forming inversion with 2 1. This 3 also 2 1. So 2 plus 1 for both the 2's. So this was very standard and easy going permutation, like first sorted and then reverse sorted. So it's easy to find out. But you will initially you should like say you should figure out why I'm saying this 4 plus 4, 3 plus 3, 2 plus 2, 1 plus 1. Is it obviously possible in all other cases in any random permutation? So yeah, if you can just see for any other random permutation like this one, I'm seeing for the next this permutation. So first of all, I'm saying what is the value of 5? 5, how many pairs, how many inverted pairs are coming from 5? So 5 and 1, 2 forming an inverted pair. So you already got 2. And obviously over here there are four numbers, 1 2 3 4, which is actually forming a good inverted pair with this 5, right? This 5, initial 5, which index at 2. All there are four elements in this way and there are two elements in this way, so 4 plus 2 is 6. Currently you got 6, and see how many this 5, how many pairs how many numbers are forming inverted pair with this. So there are two more numbers, so 6 plus 2, that's again 8. In other form there is a 8, so 5 5 is giving you, let's say, 8, right? That's right. So 5 is also giving you 8 in that case also, in this case also. And comma 3 plus 3 is giving you 6. Let's say 4 is giving you 6, and your 3 is giving you 4. You'll see like that. Okay, so 3 is giving me 4, and 2 is giving me 2. 2 is giving me 2. You can see 2 is equal to 1 plus 2. So that's about it, right? So in this case, if you see what is the 4 is giving me, 4 is giving me basically 4 is pairing up with these two numbers. So plus 2 from this side, and you'll see plus 4 from that side. So 4, okay, so basically not only this side, one for this 4, how many inverted pairs are this for? 1 2, and this 1 2 also. So and this 1 2 3 also. So 5, yeah. 5, why 1 2 and 1 2 3 from here this side, okay, after the mirror. And for this 4 there is only one, because there is only one integer after this, and this is also a good pair. So answer for this 4 is equal to 6, and then you can so on check for all the things. 3 will give you always, let's say what I told you, 3 is giving you 4, 2 is giving you 2, 1 is giving you nothing, nada. But the thing is, like everywhere, if you have permutation of 1 2 3, say like n, and the answer for this would be like, a permutation, any combination permutation of this one, then reverted with that one. Answer res will always be same. It will be 2 into something like, what, n will give you. Okay, so why I write 2? Because yeah, 2 basically 8 is coming from 2, or you can say 2 into n minus 1. Like in this, say you can say 2 into n minus 1 plus 2 into n minus 2. Like that's what I'm doing over here. Like 2 into 4 is 8, 2 into 3 is 6, 2 into 2 is 4, 2 into 1 is this. So basically this is 2 into 1 2 3 4. For 5, it was 1 2 3 4, 2 into n minus 1 and minus 2, still so on till 2. So you can take 2 common out or something like that. So r will be always equal to 2 into something like number, whatever your number, n minus 1 plus n minus 2, something like that. Now this is the answer for one. R is equal to answer for one permutation. Okay? One permutation. And how many permutations are there? There are n factorial permutation. This is the major part of this problem. How will you calculate n factorial permutation, right? So you have to calculate factorial, you have to calculate this number is nothing but, okay, 2 into n minus 1. So this is n into n minus 1 by 2, n minus 1 by 2. Then there is a thing like n into n minus 1 by 2 divided by 2 into 2. So that is the thing, n into n minus 1. So you need nothing, you just need factorial, and that's your answer will be, because you can just multiply it with n into n minus 1. So now I'm writing the answer for simple. If you have been given number n, so this is a pattern observation finding question which you can directly find. If you have been given a number n, the answer for res for n would be equal to n into n minus 1 into fact of n. This was the whole answer for this problem. Now factorial, you can do it over here, you can do anywhere. T number of test cases, number n is given to you, and let's do factorial first. Let's say int fact is equal to 1. Now while your what instead of while, you can do for int I is equal to 2, I is less than equal to n, or you can say n plus 1, I plus plus f multiply equal to I, f mod equal to mod, because yeah, you have to take mod, they have said. So I'm just writing m, yeah. So this will give you a perfect factorial of this number 1, 2, 3, and okay, so on. And then now you want to multiply it with n into n minus 1 also. Now instead of like multiplying it into with n into n minus 1, yeah, that was, or that's also what you can do. N into n fact equal to mod m f into n minus 1, let's say f mod equal to mod, and you can just see out f. I think it should work. Is the system testing over? I don't think so. Today system testing is going to over because like I don't know what system testing they are doing, because otherwise their percentage would come. I think they are not doing system testing now. Okay, so let's see. Hmm. Answer for this would be coming out like this: n into n minus 1 into factorial of that. Nothing is very strange in this. Calculating factorial is not a big task, but the thing is you should have your int m, or you can make constant in m is equal to 1e9 plus 7, integer of 1e9 plus 7. Okay, what is this coming out? No, man, like 1e9 plus 7 is that, and then mhm, now why is this? Or you can do it like that also. Long f will give you a factorial, or you can say initializing it with hmm, n mod equal to mod into n minus 1 mod of mod, and then calculating total mod equal to mod. Now let's say, okay, I think this was correct. Yeah, 04. Okay, so it's working. So let me just I cannot submit this up, system testing going on, but I can show you my submission which get passed. So it was somewhere similar to this, but I calculated factorial in some another function. But the thing was same, like long and taking mod continuously. So you can see there's a calculator factorial. This is no use, basically this array of no use. But yeah, here it is using, but you don't need this. You can just do it in one variable also. So calculator, so basically I did initialize with my z is equal to n into n minus 1 with complete mod, like how I did over here. It's pretty much same with just extra mod over here. Yeah, no, it's pretty much same. Yeah, it's exactly same. And then z into calculate of n is giving you factorial of n by calculating it. And the logic is pretty much same, greater than equal to n, or you can write less than n plus 1. And that's about it. Mod you have to take care, and at last also one mod. Okay, after this point I don't know like how many mod you do. I don't think it makes any sense. I can't even see more test cases. So yeah, that's about today's second problem. Okay, we'll cover the next one in the next video. Okay guys.